All right, let's talk about something huge. We're going to dive into one of the biggest, most, well, critical flaws in modern AI. But more importantly, we're going to look at the powerful solution that's finally, grounding our AI agents in actual reality.
I mean, we've all seen this, right? You ask an AI a question, and it confidently tells you something that is just completely made up. We call these hallucinations. And yeah, they can be pretty funny sometimes, but they really point to a much deeper problem that we absolutely have to solve.
See, when you move into the world of professional enterprise AI, this little quirk, it stops being an annoyance. It becomes a full-blown crisis.
So let's get on the same page. What is a hallucination, really? Well, think of it as the Achilles heel of modern AI. It's when the system just generates information that sounds totally plausible, but it's completely fabricated. This is the fundamental weakness we're here to talk about.
And look, in high-stakes fields, we're talking healthcare, finance, law, a hallucination isn't just some embarrassing mistake. Oh no, it can be a massive compliance violation, a huge financial loss, or even a direct threat to someone's health and well-being. The stakes here are just incredibly high.
Okay, so why? What is actually going on under the hood here? Why are these super sophisticated systems basically just flying blind when it comes to basic facts? Well, here's the kind of uncomfortable truth. These large language models, they're incredible pattern matchers. They're just predicting the next most likely word based on tons and tons of data. But here's the thing. They don't know that the Eiffel Tower is in Paris. They're just making a really educated guess based on statistics.
And that means you can't solve this just by making the models bigger or throwing more data at them. No. The real solution, it lies in fundamentally changing how an AI stores and accesses information. We need to give it a better memory.
And that brings us to the real game changer here, the knowledge graph. Seriously, you can think of this as the AI's external brain. It's a verifiable source of truth it can always rely on.
Now, a knowledge graph isn't just another database. Not at all. It's more like a web, a network that actually understands the meaning and the relationships between things. It's a lot closer to how our own brains connect concepts. Just look at the difference here. On one side, a standard database just gives you these isolated little facts, employee ID, department ID, whatever. But on the other side, the knowledge graph, it's building a rich contextual story. We don't just see data points, we see a whole web of relationships. Sarah Chen works in engineering. She reports to Michael Rodriguez. The AI can actually understand and navigate that.
And you know what? It all breaks down into three really simple parts. You've got your nouns, the things like people or products. You've got your verbs, the relationships, like works for or treats condition, and you've got your adjectives, the details like dates and amounts. It's that simple, but believe me, it is incredibly powerful.
Okay, so now that we know what it is, let's see how this new kind of memory completely changes how an AI finds an answer. This is really the core of it, the difference between just guessing and doing actual logical reasoning. This slide just says it all, doesn't it? On the left, the AI is guessing. Typical managers can approve this much. And boom, it's wrong. Big policy violation. But on the right, it's not guessing. It's traversing the graph. It follows a path. Step 1, you is a manager. Got it? Step 2, manager has an approval limit of $25,000. Okay. Step 3, $50,000 exceeds $25,000. The answer is no. See, it's a verifiable, logical path. Zero guesswork. But here's where it gets really cool. Grounding an AI in facts isn't just about preventing errors. It actually unlocks a whole new level of intelligence. It gives the AI a genuine superpower for solving really complex problems. And that superpower? It's called multi-hop reasoning. It's exactly what it sounds like. The AI can hop across multiple connections in the graph to find insights that are not obvious at all. It's about connecting dots that even a human expert might have missed.
Let's make this real with a healthcare example. Imagine an AI agent is looking at a patient's file. We'll call her Maya. And the question is simple. Which specialist should she see? So the AI starts hopping through the knowledge graph. Hop 1, pretty straightforward. Patient Maya has chronic kidney disease, which is treated by a nephrologist. Okay, specialist 1. Hop 2, Maya takes metformin, which requires monitoring by an endocrinologist. That's specialist 2.
But now, here's the magic. The third hop. The AI sees that Maya has a family history of cardiovascular disease. It follows that link to see that this requires a consultation with a cardiologist. This is a connection that might have been buried deep in her file.
And that is the key. A simple database search would never have made that connection. The AI reasoned across 3 totally different domains, her current condition, her medication, and her family history, to come up with a truly holistic and potentially life-saving insight. Now that is what I call true intelligence. So let's zoom out. What does all of this mean for the future of AI? Well, it fundamentally changes how we need to think about building systems that we can actually, truly trust.
What this all boils down to is that we're moving past the era where just having the biggest model means you win. The future belongs to AI systems that are built on the best, most reliable knowledge architecture. A solid foundation of facts is proving to be way more powerful than just a mountain of statistical patterns.
So, I'll just leave you with this one question to think about. As we all build and use these incredible AI systems, we have to ask ourselves, is this AI built to truly reason, or is it just built to guess?